Unsurprisingly, it will be about grizzly bears. I thought I wanted to provide everyone in this room with some history and background and some things that I hope everyone knows that they have to work with now relative to grizzly bears and grizzly bear management conservation province. I'm sure that most people know that about a third of our province is considered to be grizzly bear range, which is basically the forested landscapes shown on this slide on the western portion of our province. And to provide some background on grizzly bears and grizzly bear research, I wanted to give you a bit of background about our project to start, and then we're going to get into the forestry side of things. This is the first slide that I ever developed for our research program back in 1998 when our project started. And to me, this has really set the tone that everyone that comes on to work with us understands that we're to provide knowledge and tools to help with the conservation of this species. And it's that's our starting point. So everyone who joins and works with us agrees with that. One of the other concepts that we've had in our program is that we bring people with expertise and different ideas together to work together, just like these two grizzly bears are working together in this berry patch. There's a team of 18 scientists from a host of disciplines working together. That can be a challenge. You probably know that scientists, like foresters, can have some ego issues. And when you're working with a bunch of scientists, they're all fighting over the pie and money and who's going to do what and sharing data. It's a challenging exercise. Now, to me, I talk about the scientists, but scientists can't do anything without this kind of support. And usually this is the kind of slide that you see at the end of a talk. There's now about 89, I think I counted them this morning, 89 different companies and organizations who've helped fund what tools you're going to see today. And these are tools that you have to work with for not only forest management, but to help with grizzly bear conservation. So within our project, I could tell you all the kinds of things we've done, and I get to wave my hands around and go up to meetings like that, and National Geographic, very heavy stuff. But at the end of the day, if we forget about why we're doing this work, it's that little guy up in that tree watching us put a collar on mum. It's about that. That's why we do this work. Yes, there's good science. Yes, there's published reports. My CV looks good, I guess, now, but it's about that individual. Some history on sort of bears in our project. Bears and humans have a long history of being together in Alberta. The picture on the top left is from Jasper. There's about 33 grizzly bear hides tacked up to a wall there. That was a hunt in the early 1900s. There's a bear by those plum-looking fellows from the Innisfil area in the 1930s, perhaps one of the last Plains grizzlies maybe. And that good-looking fellow in the lower slide is feeding a box of, I heard it was Laura Secord chocolates to that bear, and that fellow was my father back in 1941. That's why I'm good looking. I had to get that. So there's a genetic relationship with the bear. So when we started our project, and I was fortunate to come to Alberta, and I started working with Weldwood at the time, now West Fraser, and I was fortunate enough to be a wildlife biologist. I was quite surprised that when we started our work in planning that we didn't have detailed maps from the government that I assumed we would have about grizzly bear habitat in the area in our FMA. So when we started our project, one of the first things we had to do was understand where grizzly bear habitat was. And understanding where grizzly bear habitat is not an easy thing. We took an approach, as I'm sure everyone knows, FMAs have API data, there's all sorts of new data sets now. But if you are trying to map grizzly bear habitat for Alberta, you have parks and protected areas, you have areas where there isn't good API data, and we wanted to bring everything together. So we used a remote sensing approach, and this was our remote sensing team. And over the course of a 10-year period, we started to map grizzly bear range in Alberta. And it's also nice to tell you that, so we produced this land cover map, which is more than for just grizzly bears, of course. It's also nice to put up the word completed if you're a research person, because some people think that research never ends. It's good to put up that word. So we have the seamless habitat map, but it's a land cover map. It tells us some basic things about, whether it's open conifer or tree, the real basic stuff, but it's seamless. And it transcends FMA boundaries, it transcends parks and protected area boundaries. It's a starting point. We also know that while we're doing this work about mapping habitats, the landscape is constantly changing with new cut blocks, well sites, pipelines, and there's grizzly bears dealing with that change all the time. So although the map is completed, one has to update these products, just like you have to update ADI inventory as you harvest and do other things. Of course, it's one thing to say, understand that bears change their behavior and movements in a landscape relative to annual change, the map I showed you previously. I then went to my remote sensing team a while ago and I said, annual change isn't good enough. We need to see change at I said a monthly scale. When I told that to our remote sensing team, all were, full professors and they've been doing remote sensing work for many years, they said to me, well, there was a word that would get bleeped out if it was a reality TV show. They told me I was crazy. There's a word before crazy. And then they went away and said, hey, we figured out how to do it. So they've now figured out a way to do 16-day change. And so they can look at change in the landscape on a 16-day basis using remote sensing. So think if you're putting in large cut blocks relative to mountain climbing or some other activity is going on, a development of a new pipeline. You can now understand change at a much different scale than just annual change. So one thing, yes, we have these great maps that talk about where habitat is, but what is grizzly bear habitat? Typically, we might think of, like many people, we might think of it's the mountains, once I hit the Jasper Park gates, now we're in bear habitat, as opposed to thinking, well, the first 45 minutes before you hit Edson on Highway 16, you were in grizzly bear habitat. We don't think like that. And of course, many people don't think about the working landscape with forestry and oil and gas as grizzly bear habitat, but it indeed is. So to understand where grizzly bears were selecting habitat, we, of course, had to go and capture and collar bears. I wanted to put this picture up because I'm sure some people who might understand this. This was the first bear that we caught on our project. This is bear G1. And just so you're clear that a bear shouldn't be lifting his head up while you're putting the collar on, we've got better at it. So, and I remember the pilot standing beside us, the helicopter pilot, as we're putting his collar on the bear, we've got him in the headlock, putting a collar on. He said, oh, isn't this good? The bear can help us carry the equipment back to the helicopter. So we put collars on, and they provide us with GPS points. So GPS points show grizzly bear habitat use and selection. And from that, so we've been up and down the province of Alberta catching bears and getting data on habitat use and selection. Then we worked with Scott Nielsen, who's a professor at the University of Alberta right now. Scott was doing his PhD with us, and Scott took all those points, those GPS points, combined them with our habitat maps and produced what's called an RSF map, resource selection function, which shows it's a probability surface, a probability that a bear will be at a site at a specific time. So that map on the right, the darker, think of the darker colors as represent a higher quality habitat. An RSF map isn't really a habitat quality map, but it's a good starting point. So that's one of the products that, as a forester, that you have to work with. So these maps have been created for each population unit in Alberta. So if you have an FMA in these different units, you have these surfaces now to work with. And these surfaces were created from local bears. So we didn't take bears from Jasper and build a model that we were applying to Waterton. We've got regional bears to help us understand how the local ecosystems affect habitat selection. And of course, I like that word completed because it is complete. But again, remember that as we change the landscape, we can rerun these models and produce new RSF maps, probability of occurrence maps. So, while all this was going on, because this is context, this I think is important for people to understand, there was certainly concern about population status in this province. And in 2004, the provincial government began a inventory program to help us understand how many bears we have in the province. And our project, our research project, was asked to conduct this assessment on behalf of the provincial government. By the way, that picture there's 42 grizzly bears. This is coastal Alaska, and there's a whale, the carcass that has come up on shore, and that's why all those bears are there. Bears, of course, concentrate at these kind of areas all the time, whether it's salmon or marine life that is washed up on shore. I wish counting bears in Alberta was like that, but instead, counting bears in Alberta is more like that. and that presents some challenges. I've suggested at times that the fisheries department maybe stock whales in those lakes there to help us with counting, but that hasn't been accepted. So the technique is pretty basic. It's good old, people think, if you're a summer student and you get hired to work on grizzly bears, you'll be out putting on collars and wrestling bears and doing all that kind of testosterone kind of stuff. Instead, you hand them rolls of barbed wire and jugs of blood and rotting fish oil and stinky stuff, and they never see a bear. But they put out barbed wire in the forest, and bears come into the attractant. Remember, these are not bait sites, they're lure sites, so there's a scent that the bear's attracted to. A bear usually spends less than 3 minutes at the site, and then he moves on, but he leaves behind hopefully a chunk of hair, and then we would do the genetics on it. So quickly, we did that up and down the province. It took us about 5 years and $2.4 million to get our first population count. The number is below 700 animals, and this is, some of these numbers are getting a little dated. But you can see that there's some areas of our province where the numbers are lower and some that are quite high. So if you're a member of the public, there's either too many bears or not enough. If you're a hunter or someone who wants to pursue bears from a sporting aspect, you might say, gee, you found 42 and 46, I don't believe those numbers, but you found 353 in that area, and I believe that number. It's the same technique, the same bear behavior. These are the best numbers we have for the province. So in 2010, people might know the status of grizzly bears was changed to threat. And that population change or status change was not only based on the DNA results, but I think to a large part that influenced the change in status. And the status change was based, in my opinion, on sound science. Of course, I'm a guy who's a science person. I always like to remember the RSF maps I talked about that Scott Nielsen developed. So I would go into a forest company and say, here's some great maps for you. And the foresters, like they should, say, how good are the maps? They're models, I don't believe them, blah, blah, blah. And then I'd say, well, I think they're pretty good. And they'd kind of smile at me politely and escort me out of the building. But the reality was, then we had this new data set. All those green points are from the DNA work. So the underlying surface you see there in the map represents the models. The model said, darker colors, higher probability of occurrence, the surrogate of habitat quality at some level. And then we did the DNA work that showed a pretty good correspondence to what our models predicted. So it was an independent data set that lined up pretty well with our model predictions. And that finding was found in every population unit we worked in Alberta. That makes me feel warm and fuzzy. So at the same time that the government was moving forward with recovery actions, they also asked to designate grizzly bear conservation areas in this province. And they're shown here. The areas in green are called core grizzly bear habitat, and the yellow areas are called secondary habitat. And we published a paper on how these areas were created, and Scott Nielsen was again the senior author in this paper. It was published in the Journal of Conservation Planning. As someone who's worked with foresters, the worst thing is you go into a meeting and someone pulls out a map and starts drawing lines and zones on it that you've never seen or heard about. You don't know where they come from, how they're created. That's not a nice thing, because I've been in that situation. I don't like it at all. And it's really nice to say, here's a scientific paper that explains how these areas were chosen and designated. And that's what we have to work with. So you probably know about these core and secondary habitat zones. So the big thing, and the only thing to date about those zones, which I call the management response, is open road density. So in those core zones, the management goal is to maintain open road density at 0.6 kilometers per square kilometer. And in the secondary, it's 1.2 kilometers of road per square kilometer of area. That's the only thing that we've done. So I'm going to jump into grizzly bears and forestry now. So all that background stuff is, I think, important. So certainly, grizzly bears and forestry, we know that grizzly bears are in an area that are heavily impacted by resource extraction, but not just resource extraction, it's human use at a very broad scale. So people go to recreate, they hunt, they fish, they go and quad, they pull out their fifth wheels and do all the kind of things that they like to do in forested environments. So people might know that grizzly bear habitat is basically the green zone in Alberta. These are 5 population units that I've shown here, and you can see them. The impacts of Forestry and the energy sector are evident there, and you can see the road densities that come up in that area. The overall footprint for the area of forested habitat is about 18.6%. But the big thing that you should understand, about 72% of the impact relative to the footprint in the forested zone, the green zone outside the parks and protected area, 72% of that is forestry cut blocks. So those forestry cut blocks, you know, people in this room, you guys have the best ability to manage grizzly bear habitat now and into the future. And I think you're going to play a key and vital role, and I think forestry is the group that is going to be able to conserve grizzly bears in this province. So what do we know about bears and use of forested landscapes in this province? Well, first of all, everybody better understand that grizzly bears are omnivores. You know, they're listed in the carnivore family from a zoological perspective, but they're really omnivores. They'll eat just about anything they find. And people that have had their ATV seats eaten by bears probably know that. But one of the things that you should try to keep in mind is that grizzly bears, over 90% of their diet in Alberta is plant matter. So it's grasses, it's forbs, it's berries, and fruit. So keep that in mind. One of the things that please remember, this is really important, grizzly bears are not an old growth dependent species. You might see brochures that show, you know, like I was thinking, I saw one from about 2 years ago, the World Wildlife Fund set it out, there's this carpet of green expanse. It's like, this is what bears need, you know, large swaths of undisturbed habitat. Do you know what? Grizzly bears don't eat or don't even like that kind of stuff because there's no food there. Grizzly bears are a species generalist that prefer a matrix of several stages. So they like a matrix of young and old forests. They like openings. They like edges. They utilize forest edge habitat. The edges of those cut blocks that you help create, they like and use them. So that's important to understand. They also require, just so you know, if the world was one giant cut block, bears wouldn't do well. So bears also require the adjacent stands, those leaf patches, they need those for bedding and cover and at times to avoid other bears. So if you're a female with cubs of a year and you want to stay away from males that might kill your cubs, you need that other habitat. And that forest habitat, don't think it's just for bedding and cover. There's also food in that adjacent forest stands, those mature forest stands. And they also prefer cut blocks of a regular shape. So if you're dealing with cut block design, you know, the kind of postage stamp stuff that we hope doesn't occur much anymore, those edges are not something that bears like. They like the regular shape cut blocks. But just as you're feeling all nice that you're going to save the world for grizzly bears, it's not that simple. The challenge is that as we put in cut blocks, we also require access. We don't do heavy logging in Alberta, and roads and bears is perhaps one of the biggest challenges that we have, and it's about access. And you know, to be quite frank, if we just built roads and we didn't have people using them, bears don't care. As you'll see, bears will walk down the road and they don't mind. The challenge is that we have changes in survival. So as open road density goes up, survival rates of grizzly bears go down. And you can see I circled on this slide, this is some of our own data from survival rates of the work that we've done. It's the same sort of response that you see with grizzly bear populations in the US. As road densities increase, survival rates of grizzly bears decrease. So what this means is that there's more people out on the roads, there's more of the bad guys that might shoot and poach bears. There are bears that do get hit crossing roads. I think that's somewhat rare. There's more poaching going on than certainly what we'd like. I also wanted to talk to you about this 0.6 kilometers per square kilometer. I think everyone in this room knows about risk, whether you're managing the risk of your visa balance or the risk of driving in bad weather, going back and forth to meetings. Everybody manages risk. So that 0.6 is not a magic number. It's a number that the government is using for a threshold for these core conservation areas, but it's not a magic number. Think if you were the managers now, you're managing populations, and I said, okay, you've got 42 bears that you want to maintain over time, and what level of risk do you want to take on? And you go, gee, I don't know, maybe 0.6 is the right number. If you had 353 bears, is 0.6 the same number you would use? I don't know, but I want to get across the idea that it's not a magic number. Think if road density there was one road into a watershed. Road density is at 0.004 or something. And you have 10 guys driving down that road shooting bears. Road density didn't really work, did it? It's about managing access, so that's what I wanted to try to get across. So, to just give you a sense of this road density thing, I pulled out the Yellowhead Grizzly Bear Management Unit. That's basically Highway 16 down to Highway 11 by Moorday. There are the watershed units' current densities. And you can see the ones in red are exceeding the threshold of 0.6. The darker ones are getting close, and then you've got a number that are below the threshold. If you change that a little bit, you kind of group it a bit more, you can see that there's many watershed units that are going to be approaching that threshold. And there's some that are over, and now if you're a forest manager and you're planning harvesting in some of these areas, what are you going to do? How are you going to get the areas that are at 0.75 and 0.6 down, 0.79 close to Hinton? What are you going to do to reduce road densities? And if you're working area that's currently at 0.58, it doesn't take much to put you over the threshold. So what are you going to do? That's a challenge. And I don't have the answer to it right now. But I also wanted to give you a sense of so that's what we face. You saw that sort of the road density thing. That's what we face as people that manage landscapes. I also want to give you a sense of what a bear faces. So here's a female home range. This is up in the CAPFT area. There's her location. She's an adult female. She's, I think, 8 years old this year, and I'll see soon if she's got cubs this year. There's her GPS points in 2007. All those little dots is where she physically moved around the landscape. There's the road layer that she was facing. There's a cut block layer within her home range. There's well sites, facilities, so pumping stations, etc., pipelines, and then the bear location. So a pretty busy landscape that female is trying to raise her cubs and move around. So you should, we're understanding the 0.6, what we have to manage. You have to understand what an animal is facing too. Great many challenges. And remember, the more times that she comes into contact with people that might want to shoot her driving those roads, the higher her mortality risk is. And that also goes, she has to show her cubs where to find food, how to move around the landscape, stay away from people, stay safe. And it's quite amazing that bears can deal with this kind of landscape change and coexistence with us. So, I'm now going to get into talk about science, some of the stuff we've done, talk to you a little bit about some of the challenges we face, some things that bears like. I also want to talk to you about some of our GIS applications, and I'm fortunate to have our GIS guy, Jerome Cranston, sitting with me in the audience here. Jerome has been the guy who's had the terrible task of taking all the science that comes and then turning that stuff into tools that people in the room, like you folks, can actually utilize. So Jerome has taken all the science and he's built some tools that you can use in your forest planning. One of the things is an RSF calculator. So you can in fact take an area, a watershed like this, where there's planning going on and you see the road layer. You can say there's our current RSF service. So every company that, I think I have most companies in the room here that are members of our research group, they get these map layers. So there's a map layer that's current grizzly bear RSF surface. You can put a cut block layer on that. There's your planned cut blocks. And you can look over the first 10 years to project what the RSF will do. So you go, here's the previous current condition, cut blocks, turn it to that. Now you might, again, feel warm and fuzzy and you say, look, I'll go back just so I can see the change again. Current, put in your cut blocks, and look, it improves. You've made better bear habitat. You would like to probably walk away, go to Tim Hortons and get a double-double now, but instead you have to say, oh, that's step one. Step two is risk. Because not only do you make good habitat, you have to understand the risk that comes with it. So there's a tool now, sorry, back here. So there's the current road layer. There's the current risk of that landscape. Darker black colors represent high risk for bears. There's your new road network, right? And there's what the mortality risk will do. Your the bears from an RSF perspective, you've also created more risk. So the challenge is, what are you going to do to manage that risk? What can you do? And those are the things that need to go into your planning decision. So there's the current mortality, and you can see how it's changed. So you've got tools to do this. And please, these tools are designed not to say, yes, I ran the script, there's my new risk layer, there you go, I'm done. It's to say, okay, there's my first plan on my road network. What if I change that road system a little bit? Can I reduce that mortality risk? And remember, all these models also produce output tables, so you can understand, you can actually quantify the level of risk. And that's I think, very important. So please try to use it in not just one scenario, but a number of scenarios. We also, when I say we, it's kind of the royal we, the research team, and Jerome has been helping lead this. We've developed a bunch of new applications that are coming out with support of FRIA funding this year. Some of these applications now deal with, remember that map I showed you where you've got mortality risk, or excuse me, road densities at a higher level? What could you do? Here's a tool now that you can actually click on a road segment and say, if I remove this or reclaim this road or decommission this road, how could I reduce my mortality risk? And it will quantify that for you. So you can actually go and evaluate, if you're going to try to reclaim and reduce access, you can actually evaluate that. And also, it's the best bang for your buck, because it'll also quantify what improvement there would be to grizzly bear range or mortality risk if you, in fact, remove that road. At the same time, one of the challenges, we talked about roads and poaching and mortality. Jerome has developed using LiDAR data now, the new LiDAR data set, tools that will help you assess siteability from a road network that you put in. So depending on how you want to design your cut block that might be adjacent to a roadway, you can actually look at what percentage of that cut block is visible from the road itself. So by reducing the visibility from a road, you improve the safety and survivability of a bear. Lastly, and this is quite new, we only brought this out as of Tuesday this week. We have been working, for the people that have been sort of following the grizzly bear saga in our province, you know that the province has changed our population status to threatened. You know there's a recovery plan in place, but there are no recovery targets. So in the world of forestry, you probably know all about performance measures and targets and things you have to bring to the mill and all those kind of things that you face all the time. In the world of wildlife management, it should be just the same. We should have targets. So, of course, the government hasn't done that yet, and we've been working, it's taken us about 8 years. So we have had crews over about an 8-year period that have been going every 2-week period and monitoring and measuring grizzly bear foods in the landscape. So there's 14 key bear foods. They've been going out and taking pieces of those plants every 14 days over a kind of an 8-year period. We've been taking those pieces of plants back to the lab and looking at the energy value of those plants. And this work is led by Scott Nielsen at the University of Alberta again. And his title for this work is Nutritional Landscapes. And we've developed models that look at not only fruit, but vegetation, insects, ungulates, and we figured out the food value, or kilocalories, on the landscape. So how much energy is on the landscape to help support bears? We then took all our GPS movement data of our bears, figured out how much energy they're expending moving around the landscape, to basically figuring out carrying capacity. And everyone who's got a little history with farming knows that a rancher knows how much livestock or head of cattle they can put on a given piece of land based on what the land can support. This is the same kind of concept that we've been dealing with here. And here's our first cut at this. These are watershed units, again, in the Yellowhead Management Unit. And you can see if we took the whole unit, a carrying capacity could be up to 200 bears, with a density of about 10 bears per 1,000 square kilometers. If we looked at our conservation areas only, the carrying capacity would be about 139 or 140 bears. Right now, our last estimate was in 2004. The population estimate was 42 animals. The government at that time was handing out tags when the hunt stopped, thinking there was 157 bears there. Right now, our current density, as we know, there's 5 bears per 1,000 square kilometers. This this exercise has shown the potential carrying capacity to be double that. So there's a possibility of doubling the current densities. Now, would you want to do that? Maybe not. But what it does, it puts some bounds on what's possible with the landscape configuration. So if you were trying to, we hear from various environmental conservation groups that Alberta should have 3,000 grizzly bears. Well, this shows that, at least in one unit, that those kind of numbers are unlikely. The landscape couldn't support that based on the energy available. Remember, forestry is an activity that has a significant effect on the habitat, which means links to energy, links to carrying capacity, and food for bears. So all the things you do affect this carrying capacity. So think if you're a forest company that might say, I can't stop people from shooting bears. I can do things about keeping road densities down as low as possible. But what I can do is I can maintain habitat supply for grizzly bears over time. And now we're going to have to take this new research, turn it into tools to help you evaluate harvest plans relative to habitat supply and energy for bears. And that's a huge improvement from where we are today. And hopefully it might help the government set some recovery targets. This is kind of the reality I think everyone realizes here. And by the way, there's a grizzly bear walking down that road, that little black dot. The reality is we're going to continue to explore and develop resources that our society demands. And the expectation, as we all know, is that we'll do this in a way that minimizes or reduces the impact on other resource values, which include both water and air and species at risk. And grizzly bears are part of that. So here's what I see as the challenge and what I hope that people will embrace. So what I think we need to do is strive to reduce and minimize new open road densities in grizzly bear habitat. So there will be new roads, but let's minimize whenever possible what we can do. Look at new ways to manage human use of these access features when they go in. So let's have that discussion, figure out if there are new things we can do. Manage habitat supply over time, which I just talked about, looking at both food and energy for bears, and minimize impacts to soil and herbaceous layers during harvesting. That, I believe, is very important. So any time we can go in and minimize surface disturbance, it will have a positive effect on foods for bears. And ultimately, we need to monitor the performance to ensure that our long-term conservation goals are being achieved. And I'm done talking. I want to thank you for your attention. I'd be happy to take any questions you might have. I only work in a small, so I show these maps of the province. I don't get everywhere on a regular basis. So the area that I'm working in the Kakwa area between Grand Cache and Craig, I haven't seen roads coming in. I see more and more roads going in.
And what I mean by roads coming out,
blocking roads. I don't see much of that. I do see in caribou zones with sort of more lock gates and people respecting that and seeing them closed a lot. I still see lots of gates that are left open all the time. So short answer is, I hope we can move in that direction. There's probably more that we can do and should do. And I think that, anytime you put up a berm or a gate or cement barricade, whatever, there will always be some people that will go around. But if you can stop like 90% of the people that would normally just drive it, that's a good thing. Yes?
Are black bear populations, increasing and competing for the same kind of habitat and food source?
Yeah, I don't, it's kind of, it sounds like the byproduct of the catch. So when we're out catching grizzly bears, we'll go and say, oh, it's a black bear. You know, we don't study black bears. Black bear populations, I think, are doing just fine. There is some competition, but what's really interesting, you know all that DNA work that we did? When you put up barbed wire and blood and fish oil and stinky stuff, black bears come in too. So then we had to go back and you had to separate grizzly bear and black bear. In areas where you find lots of grizzly bears, you don't find many black bears, and vice versa. Where you're finding lots of black bears, not many grizzly bears. So they share the landscape. There's certainly some competition for food, but I can't really say much more than that. Yes?
Gord, on your mortality rates and open road density, have you made any correlation or separated out road, basically on-highway vehicle as opposed to off-highway vehicle access? You know, the guys who drive down with a truck with a gun in it as opposed to the 1,000 quads with no guns.
Yeah, the road density, I think of them as like all-weather gravel roads. That's the kind of density. And, you know, on the vehicle collision stuff, you know, and maybe some people in this room have had this experience, you know, where you're driving along and bear runs out and you hit it, right? And usually when you hit it, like depending what size of truck you got, or car, the bear rolls into a ball, rolls along the road, runs off and runs into the bush. Those bears usually die. They usually die from massive internal injuries. But you get out and look at your front bumper and say, oh, it's not bad. I'm not going to report it. It's fine. And though there's vehicle bear collisions, I think there's more of those than probably what get reported. The big ones get hit by a logging truck. Yeah, you hear about those ones, but there's not. It's you know, when you think of the number of logging trucks out there, I'm really surprised that there's very few reports of any kind of vehicle mortality. Yes, in the back.
Yeah, recent media reports have come out saying the population is healthy. Is that because of just like your work, or are there populations coming in from, are there bears coming in, say, from the States and BC, or why is that?
Well, you know, step one, media reports, they get about 20% right sometimes. But what I can say is that there's been an incredible amount of work that's gone on over the last 10, 12 years, not just from our work, but other folks as well. So one of the things that people are seeing, you know, that map I put up, you know, for example, the Grand Cache unit, which included the north half of Jasper, all of Wilmore, and then at lands outside. So you got the parks and protected area, lands outside. That population there is doing very well. It was, you know, is probably close to what I might think carrying capacity could be for that landscape. So 353 bears doing fine. You go down to southern Alberta, southwest Alberta, so south of Highway 3, Pincher Creek, Waterton, the Castle. People have to understand that that group of bears is part of a population that's related to bears in the Flathead in BC, as well as Montana. That population as a whole, so Montana, so remember we draw these provincial lines and national, international boundaries. Bears don't know anything about that. There's a population in an ecosystem there that those bears are part of. When we did the estimation down there for Alberta, the Alberta side, there was 53 bears that was counted in 2007. On the BC side, there was like 170 in the Flathead. That's really one group, but at the time, the politicians wanted us to tell us just how many are on our side of the line. It's like counting fish in a lake. You know, it's the lake, not the left or right-hand side of the lake. So as a whole, with Montana, Flathead, and Alberta, their population estimate is somewhere in the order of 1,100 bears. And the population is growing in the order of between 3.5% to 4%, which is what we would normally suspect that populations of bears would grow at. So they're doing fine. So if you're a rancher and you're losing your cattle or whatever, you say there's too many bears, and that idiot who showed up counting bears here, he doesn't know what he's talking about. You know, I deal with that all the time. So someone will say it's healthy. Well, there's definitions of health. Usually when people talk about healthy, it's how many bears are. There's a large number of bears in that area. People in southwest Alberta continue to shoot and have to move bears. There's problem bears all the time. That will continue, probably because of livestock conflicts and grain bin break-ins. But is that, in Alberta, we only rank the population at the provincial level. There's groups of bears in Alberta, in my view, that are doing fine. other groups of bears are doing very poorly. And where the focus should be is trying to put our conservation effort into those areas where we know we've got some serious problems in terms of numbers. But a long answer to a short question, I apologize. Yes?
This road density thing is interesting. I'm from the Crow's Pass area, and of course, particularly in the forest industry, those roads are totally reclaimed within 3 years at the most. But yet, that satellite imagery will always show that as a road, even though it's impassable for even a quad in a lot of, I mean, that's why it's done 80 minutes to seem to work. It's always going to show it as a linear disturbance, always being 100 years.
Yeah, and I think, you know, certainly when one goes into trying to calculate open road density, you have to have really good inventory. And that's not from satellite, that's guys saying this road is closed, this is actually open. Those are the kind of things that I think we need to do. But remember, the road density thing, why do you have a road density threshold? The idea is that you want to keep the number of dead bears down. It's a surrogate, right? If we could say there's some other thing, lever we could pull and keep number of dead bears down, we do that. But if you also step back and say, okay, we have this open road density threshold policy, and if you're a manager, you say, okay, so we have this policy, so the number of dead bears should go down. Well, it's been in place since 2008. The number of annual human-caused mortalities for grizzly bears has stayed pretty well similar since at least 2006. In the order, it ranges between 17 and 20 animals a year. So, you know, the whole focus, so, you know, what I presented, you know, the habitat side of food and energy, what I think we need to do is, I'm not saying that we should throw in open road densities. I think we should minimize whenever we can. But in and of itself, that's not going to be enough to conserve bears. What I think we need to do is also, from a forestry standpoint, is focus on habitat supply. And now that we can measure and monitor and track it, to me, that would be the biggest thing that we could do. And we'll have to let the people that deal with enforcement and catching the bad guys deal with that stuff. Yes?
The 16-day change.
Yes.
That we're monitoring, does that differentiate between seasonal change and industrial change, or is it?
Yes, it's anthropogenic change, so it'd be, and it's the big stuff, like it's roads, cut blocks, well sites, pipelines, the big ticket things. And by the way, all those products that you've seen here today are available to all the partners, and we send out annual updates and all that. Anything else?
Are the Swan Hills bears a form of subspecies of the grizzly?
No, they're not. Swan Hills bears there's no genetic difference between, I mean, I can tell, for example, you know those population units I showed you there? So I can, if you give me some hair sample or a piece of tissue or something from a bear, say from Waterton, or Swan Hills, or Nordegg, I can differentiate the genetic population units. At least now I can do that. Swan Hills is part of the Grand Cache unit, so I can't differentiate between bear from Grand Cache and Swan Hills. They're the same. You know, some people think there was some remnant from the Plains grizzly. No, we don't think that. But what I can also tell you, the more bears that we move and relocate, the genetic challenges 50 or 100 years from now, we might not be able to differentiate these different units if we keep shipping bears all over the province. Hopefully we can solve that. Yes?
See any Pisleys?
No, we haven't seen any Pisleys. No, we haven't seen any hybrid bears in Alberta yet. Thank you very much.
Thanks, Chris, and thanks, folks, for coming today. I didn't expect there would be such a nice crowd for this presentation, so I'm a little bit surprised, and welcome to see so many professionals here to learn about wildlife and forest. I'm going to talk today a little bit of a grab bag of things. I'm going to give you an overview of the things you see on the screen here, but really only I'm able to touch on a few of the highlights under each subject, so it's going to be sort of a drive-by shooting, if you will. I could have given a talk on each one of some of these, and I encourage you, if you'd like to know more about some of these things, touch base with me later, and we'll even get you connected with some of the people that help develop some of this information, and I'll show you. First, a little bit about ecosystem-based management compared to traditional approaches. The key thing here is to try and recognize all interactions between people and the environment at once, rather than taking individual values and trying to manage them separately and then put them together in some form of a coherent whole later, which is sometimes tough. But it's all about conserving biodiversity in the end, recognizing the role that disturbance plays in conserving biodiversity, and maintaining ecological function over the long term. When I talk about ecological function, I'm speaking specifically about the dynamic forest. Ecosystems and biodiversity are adapted to this disturbance. It's necessary, so nature is really variable, or you could say messy. And we as humans tend to like to have nice even patterns and like to do things like control forest age class and things like that. Well, nature doesn't do that. So when we start to depart, we could get ourselves into trouble. The other nice thing in our favor, though, is nature is very resilient, and there is a lot of response to change. And so if we can fit ourselves within that disturbance overall pattern and envelope, we might have better success. In Alberta forests, forest fires are the big natural engine of disturbance. And we've learned with ecosystem-based management that if we can understand what forest fires do, that's the big disturbance agent. So if we can basically reduce forest fires and substitute harvesting and other activities, then we can maintain the overall rate of disturbance similar to what might have been maintained by nature in the past. So this natural range of variation is a key concept in this. And again, as Gord mentioned, it's a risk management strategy. We're attempting to minimize our risk by remaining within that NRV box, or the golden goose. And we believe that by doing so, we will be able to continue to extract the eggs, which in our case is timber, but it's also wildlife, water, ecosystem services, things like that. I guess you could call this the unnatural range of variation, because we've been meddling with the gene pool of dogs for quite a long time, but it is a range of variation. And it's an introduction to the concept. There's that variability that's out there, and if we try and simplify things, then we're probably not going to be successful. So back to a forestry example, if we were to take old spruce fir forest, this is an example of a natural range variation distribution. Proportion on the left, frequency on the bottom. So interpret this graph. If you were to go out into a forest, a snapshot in time, and did that repeatedly, 30% of the time we would expect there to be about 7% of the forest in old spruce fir in this example. But the range is from about 3 up to 22, so at any given point you might hit somewhere in that range. So to translate that into concepts of health, a healthy forest is one that's within that range of natural variation. But there's a way to subdivide it further, and that's called the healthy landscape model, where you look at the actual disturbances themselves and the patterns they produce, so fires, cutlocks, insect, wind, ice, that sort of thing. And they produce landscapes that have conditions that we can measure, age class, patch size, things like that. And those, of course, are the habitat that all of the species that are out there depend on. So patterns produce landscapes, and those landscapes have biological consequences, and all of those have a natural range of variation. And if we maintain that, then the economic and social consequences that we're interested in as humans are the ones that flow at the bottom, at least in theory. So another way to look at it is to ask ourselves this question. If this is an example of a natural pattern, in the case here produced by forest fire in 1956, what are we going to have to do in our management today to get these things again in the future? And specifically talking about water applications, if we put a 60-meter buffer on the Berlin River, which is what the current operating ground rules call for, it's not going to produce the same kinds of patterns again in the future. So when you look at water and riparian areas in particular, compared to upland landscapes, you see a very high degree of variability. So even within that envelope of natural range of variability, there's more variability in some parts of the landscapes than others. And because we have two disturbance agents interacting, we've got fire in the uplands and in the riparian areas, and we've also got water and the effects of that that as a disturbance. We tend to get more complex ecosystems in these areas near water. So when we look at the way we're doing things now, with this frame in mind, you see that a lot of the things we're doing now are not ecologically based. They were based for another purpose. I won't say they're wholly not ecologically based, but weren't thought out with ecological principles in mind. We have some application and interpretation issues that I'll touch on. We're trying to manage to maintain something in a stable condition, not necessarily recognize the role of disturbance, and we don't have it all integrated into one overall approach. So for example, we tend to manage upland areas distinctly from riparian areas, and what we really should be doing is managing whole watersheds with both components. The current operating ground rules in Alberta are an illustration of this. We first classify the channel based on width, or whether there's a channel there or not, and then we make an arbitrary decision of a setback buffer depending on how wide that channel was. So that's just find out how wide the channel is, measure back. It's not very ecological thinking. And this is the sort of thing you would get if you applied that to the letter of the rule. You get a very narrow strip, whatever wide width the buffer needs to be along the waterway, and then you do disturbance outside that area. But disturbance does not stop just because we decide to leave a narrow strip of forest along there. This is that same strip of forest from the photo before. You can see blowdown has been an active agent in the 10 years or so since it was harvested. Hopefully, though, and thankfully, that we don't naturally apply the arbitrary rules universally. In practice, we usually have what's called variable width buffers, and that reflects the ecology and landforms that are out there. So we rarely get those narrow, thin strips. We usually get something variable like this in the forest. But what we're looking for really is a transition, and there's a double entendre here. There's a transition between the upland and the aquatic, but there's also a transition between traditional thinking and new approaches. So now I'm going to shift into just a few examples of some of the knowledge and tools that we're able to bring to bear on this problem of how to transition from traditional thinking to EVM. First off, learning about natural history. We know that there were disturbances in the past. It's sometimes difficult for current generations to understand what the forest used to look like in the past, but we can certainly learn from that if we can understand it. So here's some examples. We are fortunate in Alberta to have a long history of old photographs that you can go back to those landscapes and look at the landscape the way it was when the original photo was taken and the way it is today. And we understand that they're different. So we can bore into that in a little more detail. Here's Foothills Research Institute mapping project of natural wildfires. And we learned a lot about this, about what wildfires are like and how their patterns are changing across big landscapes. And some of the information that comes out of that, here's just a sample. Within fires, there's a lot of heterogeneity. There's a lot of islands that the fire either doesn't burn at all or only partially burns. And you can start looking at distributions in NRV for these fires and understanding what fires look like, and then translating that information into the design of forest cut blocks, for example. Specifically related to riparian areas, we were very interested in the role of fire in these areas, and it seems that fire burns through riparian areas just about the same amounts and patterns as it burns in the uplands. So riparian areas, even though they're ecologically different, fire doesn't think so. But as I mentioned, there's other riparian disturbances, flood being probably the biggest one. And floods are very vital to maintain function over the long term, even though they have short-term effects on fish and other biota that are sometimes quite spectacular and devastating. But if we didn't have floods in the long term, you start to understand the ecological consequences of that. And the best examples of those are when we build really big dams on rivers and upset the natural water flow regime, and we start getting things like not getting floods downstream and having plains cottonwoods not regenerating naturally, for example. We've also got biotic disturbance agents, and the king of the riparian disturbers are beavers. These guys substantially. So we're interactions here between floods, beavers, and fires, and that's why riparian areas are so variable. Also, blowdown. What we've learned in Alberta is that when we leave these strips along creeks and streams, often we get blowdown, so there's another kind of disturbance, which is a natural disturbance agent, but perhaps occurring at rates and patterns that weren't common in the past. And then finally, harvesting. Are they following a natural disturbance as here, or as a disturbance itself in these riparian areas? One of the key interfaces between uplands and the aquatic environment is what's called large woody debris by fisheries biologists and coarse woody debris by upland biologists. So, as I said, it's two worlds, two solitudes. We're both talking about logs, but really, it's large woody debris to the fish guys and coarse woody debris to the grizzly guys. So what do we know about that? Well, we got some research from Alberta here that shows that the wood that interacts with the channel, almost 100% of it originates within 10 meters of the channel. So if we're worried about wood, a future supply of wood to supply that vital ecological function to streams, we need to pay attention to within 10 meters of the channel, but not within 25 or 50 meters of the channel. Once that wood gets into the channel, it plays a very vital ecological role for many years, sometimes many decades. And that was one of the interesting things, is even small logs like these, once they get into and embedded and get into an anoxic environment, they last a long time, perhaps over 100 years. Whereas a small log like that in an upland forest would be rotted and gone long before that. What about the channels themselves? Can we learn from ecological principles based on disturbance about the channels? And yes, we can. It turns out that water is the organizing agent of disturbance that forms these channels, and if the channel doesn't have enough water to do work, then you're not going to get things like gravel and sand. And that's actually a key breakpoint between a channel that only transports water and a channel that's capable of moving its bed, so sand and gravel and rocks and things like that, which is what we would typically associate with fish habitat. Some of the analysis tools that my company uses, one we have is called NetMap. It was developed in California by the Earth Systems Institute, and it's a suite of tools and databases that you can get to learn about watersheds and riparian areas and help to analyze and make management choices. I just showed a few examples here. NetMap is really a real large suite of tools, quite powerful. It actually keeps track of watersheds by reach, and you can click on any point in the watershed and it'll tell you everything about that point, but also everything upstream and downstream. Some of the examples, it can look at fire hazard, restoration planning, and management planning for, say, riparian areas and riparian management. It can be used to classify which portions of the waterways are inhabited by fish and what portions of those are most important to different species of fish. It can look at the effects of streamside vegetation and removal or changes to streamside vegetation on the temperature reading of the water body, things like that. We have NetMap coverage now for our entire FMA out just east of Jasper around Hinton, and we've started to use that information to develop our new forest management plan. We have other information though. We have high resolution color digital imagery, as you see here. This imagery has 30 centimeter resolution, so it's a very powerful tool for describing the vegetation. But we've got other tools like LiDAR. We can take the trees away, look at the same scene, and understand what the bare surface of the earth looks like. And when we're talking about water and riparian management, this is really useful information. Wet areas mapping provided by the province shows a predicted surface of where water will be close to the surface. We can combine that with things like the bare earth LiDAR here and some of the other information to get some pretty neat information about water and how to support management of prescriptions. Ecosite mapping is another thing. We have ecosites mapped for our entire